Hi, hello everyone. My name is Gilad Bandel, VP Product and Marketing at Arilou Automotive Cyber-Security. Thank you for joining me today at this presentation. Today we have an exciting subject, a very new one. We're speaking about connected vehicles, automated vehicles, connected and automated vehicles, and cooperative intelligent transport systems, and everything obviously from the aspect of the cybersecurity. So there are mere concerns regarding this subject, and I hope that we can cover today a lot of those concerns and speak about some of the solutions and protections that we can offer. So the agenda for today, just to give you a heads up of what's coming, we're going to speak very briefly about the current state of the automotive cybersecurity. We shall discuss the new technologies, the V2X, connected and automated driving, and so on. We shall speak about the threats and the attack scenarios that we can foresee. And I must say this is a new area and a lot of things are unknown. All those have influences on the automotive industry. The OEMs, tier ones, insurance companies, and so on. So I'm going to speak very briefly about those influences. Next, we're going to see protection methods. So we're going to see the whole system. It's not one thing, one way to protect, but it's a whole system that we need to understand. How do we look for plausibility, misbehavior? How do we detect them? How do we report them? How do we react to it? And we will conclude with a summary in short take-home message. So a few very brief words about the company that I work for. I work at Arilou Automotive Cyber-Security. We were established back in 2012 by two veterans of the Israeli cybersecurity core defense forces. The company was acquired in 2016 by a large European software supplier called NNG. So today we're an independent and proud member of the NNG group. This is just to acknowledge the value the company has and its novelty and the many patents that we have and new products and solutions that we come and offer the market. Just to mention a few of those solutions. So the flagship is the Sentinel product line. Those are firewalls and intrusion detection, intrusion prevention systems. To mention two of them, there are more, but the important ones are Sentinel ETH, which is an IDS and IPS for the new and emerging technology in the vehicles, the automotive Ethernet, and the Sentinel CAN. The Sentinel CAN is an IDS and IPS fully software implemented in gateways for the CAN bus, and it has the extension for the SAE J1939 commonly used in commercial vehicles. So for the common vehicles that we have, common cars, we have full coverage both for Ethernet and CAN bus. We also offer the secure boot for ECUs, especially those that are equipped with the SHE interface. Those we see that the major interesting processor that need protection. In addition, we offer some professional services. We are consulting for compliance for the ISO SAE J19, for the ISO SAE 21434, and we offer the TARA, which is part of the 21434, but due to its importance for threat analysis and risk assessment, we offer it separately. So this is a very, very brief introduction regarding the company. Let's move and speak a bit about the current state of the industry. So doing this very, very briefly, just understanding what are the influencing factors. We're migrating from CAN bus to automotive Ethernet. Ethernet and IP and all the other protocols are well-known protocols by hackers, so they pose a higher risk. Automotive Ethernet can be considered nearly a must for moving to new technologies, high-speed and flexible networks. So moving to connected vehicles, moving to automated driving, moving to cooperative driving require a lot of bandwidth and a lot of flexibility in the vehicle. So we must move to Ethernet. Canvas cannot accommodate this anymore, not in the long term. The Ethernet has a lot of known public exposures, so it comes with benefits, but it comes with a price that hackers already know it. And there are many available tools, especially focused on Ethernet. So when we are going to see Ethernet, we're going to see a lot of already existing attack scenarios and rootkits, as opposed to Canvas, which those things weren't there because it wasn't a known protocol elsewhere except the vehicle. We raise in complexity. So new software in the vehicle for all those new functionalities come with new vulnerabilities. New vulnerabilities means exposures that can be used by hackers to attack a vehicle. We increase the computerization power and the number of computers or the complexity of computers, and they come with a risk, obviously. And the most severe thing that the vehicle is connected. An infinite number of connections, and we're going to speak about a few of them, so I'm going to skip now the list, but just mention that this is the case. So what are our major concerns? We are concerned for the safety, reliability, and privacy. All those can be compromised, and we want to make sure that the vehicle will drive safely on the road, will not cause accident, will be reliable. That means when you try to turn it on in the morning, it will turn on, and will keep the information private. A lot of information is in the vehicle, a lot of private information. Keep in mind that car sharing, you have your identity in every time in a new car. When you rent a car, every time it's a new car, a new vehicle, you connect your cellular phone, you expose there a lot of information. So the only good thing that we have is that there weren't yet real incidents, no casualties, nobody really died due to a cyber attack, and hopefully this will be the case since we're going to protect the vehicles. This is totally different than the IT industry, where every day you hear about a ransom attack and the information theft and so on. So the awareness in the IT industry is much higher than in the vehicles in the automotive industry. This is not to say that the risks are not there, they just weren't visible yet. The real driving force, and this is more or less the only time that I'm going to mention any standard or regulation, is the UNECW P29, the UN Regulation 155, which emerged, which as of 2022, any new vehicle type, and as of 2024, any new vehicle on the road will need to be certified. So the regulator is aware of the cyber risk, and especially a major factor in this is the understanding that vehicles are going to be connected and are going to be automated, which increases the risks, and the regulator acknowledges this and takes action in this direction. So let's look at the new technologies, namely the V2X, vehicle to everything. And vehicle to everything means a lot of things: vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure, vehicle to the cloud, vehicle to the grid, vehicle to device. Every letter that you have in the alphabet is used for something. The idea is that there is communication between the vehicle and the surrounding. Something happens there and someone is speaking with someone else along the way. There are a lot of benefits that come with this thing. I will give just 3 short of them, but there are so many of them. For example, a do not pass warning. Since the vehicle has information about the upcoming traffic, and you try to pass someone else, but you cannot see, the system will warn you that there is an incoming vehicle and you should not pass. So this obviously increases the safety. Left turn. Again, there is a left turn assistance. Will tell you if there is a vehicle on your left. If you're driving in the UK, then on the right. And it will assist you in making a safe and good left turn. So it's another value, another thing that V2X can help you. Optimizing your fuel usage, preventing emergency brakes. This is, for example, the red light indication. You'll get an indication that ahead of you is a red light, and then you can plan and you can optimize, and the vehicle can optimize the driving speed so it will reach the green light when it's on, and you'll not need to brake and then restart the vehicle. It will just improve your driving experience. So there are many, many values that can be generated with V2X. A lot of monetization can be done on the V2X. It is very much connected to the smart cities, other IoTs on the side. So on the roadside, there are roadside units that include information and can communicate with the onboard unit in the vehicle. It can communicate with authorities, with legal government, advertisers. You think about it. So there are many good things that come with the V2X. A few things that a bit technical. I'm not going to go very deep, very technical in this presentation, but just as a high level. In terms of the network infrastructure, there are 2 standards. The good things in general about standards is that there are so many of them. So here we have 2 of them. The DSRC, which is a Wi-Fi derivative from IEEE, mostly in Europe. I can't say where it's going to happen. So for the long term, there might be a mix and match. I will give you my personal view on what is expected, but I cannot guarantee this is exactly what's going to happen. The second standard for the RF, for the interface, is the cellular V2X, mostly in the US. My personal position is that the cellular will be the winner, but this thing is definitely not settled yet. So we can expect ahead of time things to come. Regarding the messages themselves, in theory, each message can run on any infrastructure. There are 2 standards, again, the European ETSI standard and the US SAE. So each standard has its own message name and message formats. But the good news about it is that although the message formats are different and the message names are different, the substance is more or less the same. So in all of them, you will see some kinds of early emergency early braking lights as a message. You would see the emergency vehicle message. You'll see a weather warning, and so on. The idea is that even if it's called DEM or CAM or BSM or TIM, whatever it is called, at the end of the day, the same information is available there. So you could have a generic view of the protocols, and regardless of the actual implementation, the information that you get at the end of the day is the same information. It's a pity that there are 2 standards and the humankind was not able to settle for one. So we'll see vehicles which are dual with two standards. Some of them will be manufactured with one standard, others with other standard. It's very interesting what happens if you cross the border and you don't have the local V2X, so it won't work. So the idea is that at the end of the day, I would very much like to have one standard that will be shared among everyone, and this will make life very easy. Let's look at how things look when you're using the V2X. So even today, most of the vehicles are already connected. They're connected to the telematics for diagnostics. The infotainment is connected to the internet, so you can download the application and communicate in real time with maps, traffics, digital radio, and so on. Internet radio. You might have a dongle from your insurance company to follow you that you are not driving in a dangerous fashion, and will meter your driving so they can charge you per kilometer, not flat rate. So the vehicle is connected, and those are cellular connections. I'm not speaking about Wi-Fi, Bluetooth, TPMS, key fobs, and so on. So there are so many connection options to a vehicle. The V2X is yet another one. So we're just adding one more connectivity to the vehicle. So even though today the vehicle is connected, the V2X will add one more interface to the vehicle. So here we have example of vehicle to the cloud, vehicle to pedestrian, vehicle to vehicle, vehicle to infrastructure. Let's speak about automated driving. So automated driving, you put the car in an autopilot, so you have cruise control and you have keeping the lane, so the vehicle is driving on its own. Okay, today it's not 100%. It cannot drive in all driving condition. It's called ODD, so it cannot cover all ODDs, not all weather, not all driving condition, not all terrain. But we entrust our lives very much into the vehicle. And as time goes by, when we go from level 3 to level 4 and level 5, in level 5, a vehicle will be able to drive in all conditions, all weather, all terrains, urban area, highways, and so on. There will not be a wheel. Okay, so nobody will be at the wheel, and we entrust our lives in the hands of some software developers. Software is very, very complex. To have a vehicle which is driving on its own, it's not as easy as it seems. It's very, very complex. We are not yet there. But as we go in that direction, more bugs, more exposures, more risks arise. Now, let's connect the two. We have a connected and autonomous vehicle. It's also called connected and automated driving, CAD. So here we actually multiply the risks, because from one perspective, we had a connected vehicle which can be attacked remotely. And from the other side, we have a software running the vehicle. And the attack scenario will be someone from outside will use the cellular network to attack the vehicle, which is not attended by any human being or partially attended, and can take over a vehicle. And this was already demonstrated more than once as possible. Let's look at the next phase. The next phase is cooperative driving. Cooperative driving means that you have, for example, a platoon of tens of trucks driving along a road. All of them communicate one with the other. So it's very efficient, very effective, very safe, as long as nothing happens. You can keep the vehicles very close one to the other because you control the speed of every single vehicle. You don't need to keep 2 seconds apart from one vehicle from the other. They all drive at the same speed. They all drive along the same route. We are in the right direction. But the thing is that if it's connected and automated driving and cooperative driving, we just multiply it again. Because if we created something in the first vehicle which creates an attack, it will attack the whole platoon. So if I create a fake blockage on the road, which is identified by mistake, obviously, by the first vehicle, the whole platoon stops. And the damage that I created is not on one vehicle, but rather on the whole platoon. So this is the reason why moving to cooperative and intelligent transportation system has a lot of value in it, but also many more attack scenarios and many more risks that need to be tackled. So this was a short introduction into this field. I gave you quite a few ideas why this is a good thing and why it is beneficial to have it. And from the other side, I raised a few concerns regarding the cybersecurity associated with the fact that it's all connected and to the fact that it's all computerized. And this combination has its risks. Let's look at the potential attack scenarios and threats. I'm not going to show exactly how an attack is launched. I'm going to give the idea of how this thing can be done and what threats can happen. I'll be more than happy to share with you the presentation later. I'm not going to go through all the threats, but just give an idea of what can happen. So, how an attack would look like. An attack would look like someone, a hacker, wherever he's located, and can be located anywhere, well, anywhere on the globe, through the cloud, through the internet, has connectivity to the vehicle. Yes, there are many things that we can do along the way to protect and prevent, but still, internet, cellular means there is a way to reach the vehicle. From the cellular antenna, the connection will be to the OBU. OBU stands for the onboard unit. This is the device which communicates and speaks V2X. As you remember, there are two protocols, so it can support one or both of them. The OBU has two connections, one of them to the cellular network and the other one in vehicle. In vehicle can be CAN bus, as appears in this drawing, but also can be Ethernet and can be both. So the OBU can be also a gateway that can communicate both with CAN bus and with Ethernet in parallel. So the attack scenario would be through the OBU, go through the CAN bus or through the Ethernet, and the attack is used in the vehicle. This is our main concern. There are many other scenarios that we can discuss, but not today. I want to focus on the main case, the main idea that is of concern. So we have the in-vehicle network, IVN. This is the in-vehicle network. We have the OBU, which is connected to the rest of the vehicle. And we have the connectivity through the gateway connected to other vehicles around us and to the infrastructure. RSU stands for roadside unit. So we have a V2V, V2P, V2I connectivity. We have connectivity to roadside units, which, by the way, can have edge computing there and infrastructure on the cloud. This is the high-level architecture. Looking at the attack surfaces, and as I said before, I will discuss this here. So those are some of the many interfaces and attacks that we can launch. So it can go through the Bluetooth, through the Wi-Fi, RF through smart keys. We assume, and this is something important to state, we assume that we are not addressing physical attacks as a major threat. Because the idea is that if I can reach your vehicle and can play with one of the ECUs, it would be much easier to plant a bomb under the seat than try to get you crashed through a cybersecurity attack. But physical attacks are interesting as well. Again, not today. So we have the internal vehicle communication. We have the external through all those interfaces, telematics, Bluetooth, Wi-Fi. USB is physical connected, OBD is physical connected, but the main important interface is the V2X using either DSRC or V2X, CV2X. What are the threats? I'm going to count a few of them. The drawing explains how things can happen. Not going to go into those details too much. One of the threats is threat to confidentiality. That means that we are compromising here the privacy. The information about the vehicle in general does not identify itself when sending V2V messages, so it's anonymous. But if we leak something like a PII, then someone can identify the vehicle, can identify the data from the vehicle, and information leakage can occur. So this is one of our concerns. Threat to confidentiality. In general, the information is cryptographically signed, and only if there is a certificate authority, the PS or whoever listens to the traffic can validate the source of the information. An attacker might be able to capture this information and either try to replay it if there is no check of the freshness of the message, or try to alter it if he's able to re-sign the message in some fashion. So this is one of the threats. The most important thing that we need to keep in mind in all cases is that even though we might have very secured communication channel, this does not account for a compromised device. So you might have a compromised device at the end, even with the best cryptographic means that you have, the data itself will be corrupted, will be rogue data. So we cannot rely on pure encryption mechanism, neither in the vehicle nor external in the vehicle of the vehicle. So even if you have in the vehicle SecOC, or you have MACsec or IPsec, and even IPsec end-to-end, it would not account for a compromised device. And if we go one step further and we have also a secure boot implemented in each ECUs, still it does not account for external information which arrives to the vehicle. It does not account for dynamic manipulation of module loads. So you know what you loaded at the beginning, but not dynamically. So there are a lot of concerns here and a lot of means to protect, but no one of them is 100% immune. Let's look at a few more cases. Threat to availability, a denial of service attack by jamming, by overloading the system, by entering data which will cause crashes. RF jamming and things like this can cause the V2X to die. Non-repudiation, this is more has to do with transactions, like bank for transactions. This is to say that if it was me, then it is 100% me, and I cannot deny that it was me. So if I have a transaction made, and someone has the registration that this transaction was made by me, this is a proof that it was actually made by me and not someone else. So an attacker might try to impersonate and try to play on my behalf, and then it's a bit hard to prove that it wasn't me because, for example, he has the keys. Threat to authenticity, impersonation attack. Again, there's something which is called CYBERSECURITY attack, which means that I'm changing my personality very fast, so you cannot even follow me. So this is again a threat and a risk to the network in general and V2X specifically. Threat to accountability, again, duplicate vehicle. A vehicle caused an accident, it has my identity, and then someone comes to blame me that I caused the accident even though it wasn't me. So it's hard to keep the accountability precise in those cases. Threat to authorization, again, someone else might try to access the resources although not authorized to do so. So this is a threat to privacy and can be used as an attack on a physical infrastructure and cause safety concerns. So those are the major risks and major threats to the V2X. Many of them are common to other networks and occur in other environments as well. But the important thing is that there are specific implementation and specific cases in the V2X which do not occur somewhere else. So you cannot take an IT firewall or an IT intrusion detection system, install it in a vehicle, and hope that it will block the V2X attacks. No, it doesn't work this way. You need a dedicated, devoted, and independent system that will analyze the V2X traffic to cope with those attacks. Let's briefly look at the influences on the automotive industry as a result of the V2X and connected vehicles, automated driving, and the risk of cybersecurity. So, yes, the automotive industry is working very, very hard to come with new technologies, new functionality. This is a differentiating factor. This is a main differentiating factor between OEMs, between vehicles. This is the way OEMs how to sell more cars by creating a state-of-the-art, coming with new ideas. All those innovations are not free of charge. They come with an elevated security risks. And as I said, the risks are impact to safety, reliability, and privacy. There are pressures to make sure that there will be no harm done. This comes from the CEO, which doesn't want anything to happen while he's serving in his position. It comes from professionals in the industry which understand the risks. It comes from insurance companies which want to minimize the risk and manage the risks. It comes from customers which expect the vehicle to be safe. And obviously, I'm not willing to pay one more dime for a safer vehicle. But the most dominant influencing power is the regulation, namely the UNEC WP29 UN Regulation 155. And to be able to comply with this regulation, one needs to follow a standard. The most common standard is the ISO SA 21434, which is the equivalent to the ISO 26262 in the functional safety. So this is the cybersecurity protection of a vehicle. It's also interesting to look at the ITU new and emerging standards, the X 1370 to 1389, interesting standards, some very new ones up to date, was looking at them and understanding them, because they have a lot of value. So let's look at the protection options that we have. So this is after we conducted, let's say we are following the ISO 21434 and we conducted a TARA process. We have our CAL, the cybersecurity level that we cybersecurity assurance level that we need to achieve, and we need to find a way how to protect the vehicle and the connected vehicles specifically. So what's the idea? What's the challenge? The challenge is that the V2X communication channel provides security but no content examination of possible cyber attacks. So yes, we have cybersecurity cryptographic means, but those cryptographic means do not inspect the content of the message. They just inspect the envelope. So a vehicle might take unexpected course of action in case rogue information is being injected over this very, very secured channel. What should be done? We should inspect the traffic in the OBU. We should do some deep packet inspection, deep content inspection, make sure that the incoming messages are plausible, and there are a lot of parameters that we can check plausibility of messages. And we need to discover misbehaviors. Once we have a misbehavior detection, we need to react to it. We can direct it locally, at the community level, at the global level. It's not enough that we look at individual messages. We need to look at a bunch of messages, and we need to fusion this information with other sources, such as vehicle sensors. So if the vehicle is doing 100 kilometers per hour and we receive a report that the vehicle in front of us is doing 10 kilometers per hour, we should disregard this message, because it does not make sense. It does not align with the fact that our vehicle is doing 100 kilometers per hour and does not see anything in front of it obstructing the road. So this is an example of a misbehavior that needs to be detected. All those rogue messages should be discarded, and we should not be taking them into account. And obviously they need to be reported, so other vehicles and the whole system might be able to protect itself. So let's look at the mechanism that we have. I spoke about the cryptographic mechanism. I just want to give a few more words here. We have a signature generation process. We have shared keys, common secret, shared secret. Somehow the keys were being shared. And then we can take the message and we can sign it. When we sign a message, we provide information to the other side regarding the origin of the message, the integrity of the message, and the freshness of the message. That means that anyone which is reading the message, if it's not encrypted, can read the content, but the message cannot be altered, it cannot be manipulated. There can be no replay attacks. So if the message was recorded yesterday, I cannot replay it today. And obviously I can identify that the source of the message is a trusted source. Even though I don't know exactly who is the source, I can still verify that it is a trusted source. So this mechanism ensures against tampering with a message on the way. It does not provide a guarantee against many other scenarios. For example, a compromised ECU, which is injecting rogue data through this very, very secure channel. So we need to take more actions. The way that we would take those actions is by taking the V2X message, through the OBU and handing it for inspection. The inspection goes to the Sentinel V2X, which is the Arilou V2X inspection engine, perform the IDS and the IPS function, and it is inspecting the message. If the message complies with all the rules, and I will speak in a second how we got those rules, and does not misbehave and is fully plausible and is in line with everything else, then the message carries on and continues the route inside the vehicle to all the other systems, the ADAS and wherever it should go. In case the message violates the rules, if the OEM chooses so, it can be discarded. It's not a must, but we strongly suggest that such messages are going to be discarded. Those are not safety messages, so nothing terrible happens if we have a false positive and we drop a legitimate message. And we need to report. So we need to report the misbehavior and we need to take action if we saw this misbehavior. The more severe the misbehavior is, the more severe reaction that we need to take. Let's look a bit deeper into how this thing looks like. We need to protect on two fronts. So the OBU is attacked in theory from two fronts. One of them from the cellular inside the vehicle, and this is the main concern. In addition, there might be a scenario in which a compromised issue in the vehicle is injecting rogue information into the V2X, and we need to protect, therefore, both the in-vehicle network interface and the cellular network interface. So this is a two-front battle that we need to win on both sides, so we keep both the vehicle safe and the network and other vehicles safe as well. Here there is a table that explains for all the cases of V2 something, V2V, V2E, warning propagation, V2V platooning, beaconing, V2I warning, information exchange, communication, and so on, how it should be protected and what things should be taken into account. So you see that this matrix is quite comprehensive and we should take into account many cases, and for each case we need to take into account various scenarios so we can protect against unwanted activities. Let's look at the process, how we can generate the rules and how the inspection engine would work. So first we need to perform an offline learning phase. In this offline learning phase, we need to learn about the messages, we need to learn about the vehicle itself, the sensors of the vehicle, and we need to generate a rule set. This rule set is being uploaded into the OBU of each vehicle, and the Sentinel V2X is using those rules to inspect the traffic. So the traffic is continuously inspected with deep packet inspection, deep content inspection, obviously stateful inspection, because we need to see changes and we need to take a few messages and correlate them to understand if something happened. Once we see any deviation, any misbehavior from the profile and the rules generated, this is regarding as a security event. And then we take action. Action means reporting it, for example, through the telematics to the vehicle SOC, and we can prevent the attack by discarding the V2X offending message. Let's look at some algorithms, some things that we can do and what we're looking for. So those are plausibility verifications. Let's look at a few of them. Range plausibility. We need to check that the sender is inside the maximum range. So if we receive a message from 150 kilometers away, it can't happen. So something went wrong, someone is trying to inject rogue traffic. We need to look at the position of the sender. If the sender is located in the middle of a forest, it does not make sense. The position needs to be consistent. We need to check intersection. So there is no case in which two vehicles are located in the same place at the same time. So if we receive reports from two vehicles from the very same location at the same time, it does not make sense. We need to look at the speed. So if the advertised speed is of 1,000 kilometers per hour, again, we can disregard the message. It's not it's a fake one. We need to look at, for example, speed consistency. If we receive two beacons from the same sender, they need to be apart at a reasonable distance. So no way he was covering 200 kilometers in 1 second. Cannot happen, and so on. So there are many other cases that that we can look for plausibility, and we can identify if a message makes sense or does not make sense. Let's look at a detection of a misbehavior. So in this case, we're speaking about an EEBL, early emergency brake light, in which the white vehicle is sending a fake message, and the red car would perform a hard brake because we see that it receives a message that there is a roadblock ahead, or someone braked the vehicle ahead. So to make sure that this thing makes sense, we need to check if it complies and is in line with other indications that we have. So we need to have some sensor fusion. We need to collect sensor information from the vehicle, from other vehicles, fuse them together, and compare the message with the rest of the sources of information that we see. And if we see that a message does not make sense, then we need to drop it and report it. Obviously, if it makes sense, that we need to take action, and we'll speak about how this thing is done. So the whole process of misbehavior detection is divided into two parts. One of them, the data capturing. Here we take the data, filter it, clean it, and make sure that we use the data and all the data that we have. Then we feed the data into the inspection engine, and we select the data and we detect events. If there is an event, then we need to notify. Now, this is a machine learning, artificial intelligence machine. So whatever it learns, it feeds back into additional data. So this way, the data improves itself from time to time. And it is using whatever history and past experience it had for the future. So this is a learning system that only improves itself. Need to note that this is not a simple computing process. We need a very strong, powerful computer on board. So this will add to the cost of the vehicle and will require additional computing power. You cannot take a microcontroller, a microprocessor, and use it for this purpose. You need a much, much stronger computer. Let's look at the misbehavior detection flow. Some of the messages can be checked individually. For example, look at the format and make sure that it is according to the standard. Let's see that it is consistent. Let's see that it is valid. So those things can be done on a message base. Some things are done on a node base. So this is collecting information from additional sources, when we can validate against additional things. So this would be the overall process. We start with the classification, perform the checks, and use the information bases to generate the insights and the understanding if anything went wrong. Now comes the questions, what do we do with this information? One thing that should be noted that each vehicle is awarded a certificate, and there is a certificate authority which is managing the certificates. Once we detect a misbehavior, we need to react to it. And one of the ways to react to it is to mark that offending vehicle as such. And the way to do it in the most harsh fashion is to revoke the certificate. It's called CRL, certificate revocation. So we can revoke the certificate. That means that as of that moment, any other vehicle that receives messages or any other device which receives messages from the offending vehicle will disregard them. So this is the way to punish an offending vehicle that created some misbehaviors. This is the way the system protects itself. Now, this is not a black and white binary case. It can have several levels. So for some minor misbehavior, the reaction might be no reaction. For a bit more harsh case of misbehavior, we might decide that we just send a message. Even worse, we can create a warning and we can deduct some points out of that vehicle score. So if this misbehavior or other misbehavior repeat, then we will understand that this sender is problematic. Then we can go to a passive revocation of the certificate. That means that locally we decide that we do not trust that vehicle anymore. Worst reaction would be active revocation, in which the certificates are being revoked by the certificate authority, and that vehicle is no longer a member of the trusted V2X community. How this thing works, it works in layers. Layer 1 would be the local layer, in which we do it based on sensor fusion and local vehicle detection and revocation mechanism. Then we can go to the cooperative level, for example, a platoon, and then a platoon will totally disregard a source of information, a sender. And then we can go to the global. Then the vehicle is totally disconnected from V2X. So you can see here that we have level and layers of detection and revocation scope that can react in a right fashion to different cases. Let's look at the end-to-end process. So if we have, for example, a ghost vehicle, and we detect this as a misbehavior because there isn't such a vehicle there. We did not find it on the LiDAR, not on the video. Nobody else reports the existing of the vehicle, so we know this is a misbehavior. We are reporting it, and we are reporting it to the misbehavior authority, which is managing the misbehaviors at the platoon level, at the global level. And if this thing is a severe case, then we report it to the certificate authority, which will revoke the that vehicle or that source of information certificate altogether. So from all purposes, it just disappears. Important to state that we are not only on the V2X area. There are additional sources of information such as databases, video cameras, other smart city sources of information, telematics, and so on. So if we look at the overall picture of protecting the connected and the automated vehicles, we need to take all those sources, feed them into the cloud, and bring the information to the Vehicle Security Operations Center for forensics and analysis. So let's summarize, and I'd like to give you some take-home messages. We saw that the V2X, connected vehicles, automated driving, connected and automated driving, cooperative intelligent transportation system are the future, and they come with a lot of good things, but also with some risks, and we need to take into account those risks, and we need to manage them so we will be able to drive our roads in a very safe mode and comfortable mode. And to make this happen, we need to protect against cybersecurity. How do we do this? Cybersecurity, it's not an add-on. It's not something that you add at the end. It's not a color paint to the vehicle. It's a central item, and you need to take into consideration from day zero. So a secure by design approach is a must. We saw that the major force is the regulation, but it's not sufficient. You cannot do only a check and say, yes, I comply with the regulation, I'm fine with it, and just need someone to sign me here so I can send my vehicle. It needs to be part of the corporate and organization responsibility, and it is as equal, as important as the regulation, even more. So you need to create awareness, and you need to train the employees to make sure that there are no cybersecurity leakage along the way in the supply chain or at home. There is no one way to protect the vehicle. You need a multi-layer defense in-depth approach in which you add one layer and another layer and another layer. So you use secure software development, and you use secure boot, and use cryptographic means, and you use intrusion detection and prevention systems. All those need to come together. The software and the hardware needs to be performed with security in mind. Keep in mind that the only dedicated, devoted, and independent protection component in a vehicle is the firewall or intrusion detection, intrusion prevention system, because the only thing that it is doing is minding about cybersecurity protection, and it needs to oversee the in-vehicle traffic, the external traffic, the V2X traffic, so we make sure that nobody penetrates the vehicle. Last thing, take along a professional company to guide you and support you along the way. Nobody knows everything. You need to consult, you need to use professionals in the industry to work you along the way to reach a very good and stable system. For more information, you're welcome to visit our website at arilotech.com. And please follow us on LinkedIn. We're very active there. We come with new information, valuable information that can help you from time to time. We try to do it as frequent as possible, and I'm sure that you can find there a lot of valuable information that can be of use. So thank you very much, everyone, for joining me today. It was a real pleasure being here. If there are any questions, please use the chat box, and I will try to answer any question that you might have. So if you have any questions, please go ahead and type them now. If not, I'll be more than happy if you approach me by email, and I will extend any support needed. So I see there are no questions. So again, thank you very much. And that would be all for today.